Are renewable energy sources like wind and solar truly cost-effective? Today, we dive into the actual figures behind these green technologies. Hello and welcome back to our channel. In this episode, we're revealing the real costs associated with wind and solar power. From the hefty initial investments to ongoing maintenance, we'll look at whether these technologies can sustain their promises of a greener future. When we delve into the economics of wind and solar energy, the initial investment and installation costs take center stage. For wind energy, setting up a single turbine involves a complex array of expenditures, chiefly determined by the turbine's capacity and the specifics of the location. On average, the cost per megawatt of wind turbine capacity can range between $1.3 million and $2.2 million. This variability is influenced by factors such as the turbine's design, the logistical challenges of the site, and necessary infrastructure like foundations and electrical connections. In contrast, solar power presents a different financial landscape. The cost for installing solar photovoltaic (PV) systems has been decreasing significantly, making it an increasingly attractive option. As of recent market data, the average installation cost of solar PV hovers around $89 per watt. This translates to roughly $16,000 for a standard residential system capable of producing about 6 kilowatts before any government or state incentives are applied. These incentives, which can include tax rebates and grants, often play a crucial role in reducing the upfront financial burden on homeowners and businesses opting for solar energy. These initial costs are pivotal not just for potential investors or adopters of green technology, but also for policymakers. They set the stage for financial planning and long-term energy strategy, highlighting the need for supportive policies that can mitigate the substantial upfront investments required for renewable energy technologies. By understanding these costs in detail, stakeholders can better navigate the economic landscape of transitioning to renewable energy. Maintenance and operational expenses play a critical role in the overall economics of wind and solar energy systems, influencing their long-term viability and cost-effectiveness. Wind turbines require regular maintenance to ensure optimal performance and longevity. This includes routine inspections, lubrication, replacement of worn-out parts, and sometimes major repairs such as gearbox replacements. The operational costs for wind energy can vary, but on average, they range from 1.2 to 1.5 cents per kilowatt hour produced, accounting for about 20-25% of the total cost of energy generated over the turbine's lifetime. These expenses cover everything from labor and spare parts to insurance and administrative fees, reflecting the complex logistics of maintaining large-scale wind installations often located in remote or hard-to-access areas. Solar PV systems are generally low maintenance compared to wind turbines. The primary expenses involve periodic cleaning of the solar panels to maintain efficiency and occasional checks of the electrical systems and inverters. The operational costs for solar are significantly lower, typically around 0.5 to 1 cent per kilowatt hour, which is less than 10% of the total energy cost. This lower maintenance requirement is a compelling point for solar energy, especially in distributed energy systems like residential or community solar projects. For both types of energy systems, ongoing monitoring and efficient maintenance strategies can greatly reduce the likelihood of costly repairs and downtime, enhancing the overall economic proposition of renewable energy investments. These operational aspects are essential for stakeholders to consider when planning for and managing renewable energy resources, ensuring that they remain both financially and technically sustainable in the long run. The longevity and efficiency of renewable energy systems like wind turbines and solar panels are crucial factors that determine their overall cost-effectiveness and impact on the energy market over time. Wind turbines typically have a lifespan of 20 to 25 years. Throughout their operational life, the efficiency of wind turbines can be affected by factors such as wear and tear on components, the local wind resource variability, and advancements in technology. Maintenance strategies that include regular inspections, timely repairs, and upgrades to components, such as blades and gearboxes, are essential for maintaining the efficiency and extending the lifespan of these systems. Despite these challenges, modern wind turbines are increasingly robust and designed with advanced materials and technologies that minimize efficiency loss over time. Solar panels commonly come with a warranty of 25 to 30 years, during which they are expected to maintain at least 80% of their initial efficiency. The degradation rate of solar panels is approximately 0.5% to 0.8% per year, depending on the quality of the panel and environmental conditions. This gradual decrease in efficiency can be influenced by factors such as exposure to harsh weather, temperature fluctuations, and physical wear. However, improvements in photovoltaic technology continue to enhance the durability and lifespan of solar panels. reducing the overall impact of efficiency loss. In both wind and solar energy systems, ongoing research and technological advancements are continually improving the durability and performance of these systems. For instance, innovations in materials science and engineering have led to more resilient turbine blades and more efficient solar cells that withstand environmental stresses better and convert sunlight to electricity more effectively. The continuous improvement in renewable energy technologies not only boosts the efficiency of these systems, but also extends their operational life, making them more competitive with traditional energy sources. This progress is vital for reducing life cycle costs and enhancing the sustainability of energy infrastructure globally. The economic impact of renewable energy sources like wind and solar on energy prices is significant and multifaceted, affecting everything from the cost of energy production to market prices and consumer bills. Renewable energy technologies, particularly wind and solar, have seen dramatic decreases in production costs over the past decade. These reductions are driven by advancements in technology, economies of scale in manufacturing, and increased efficiency in installation and maintenance. As these technologies become cheaper to deploy and operate, the cost of producing electricity from renewable sources continues to fall, which can lead to lower energy prices for consumers. Renewable energy sources are increasingly viewed as a stabilizing force in energy markets because they reduce dependence on fossil fuels, whose prices can be volatile due to geopolitical tensions, market dynamics, and other factors. Solar and wind power, which have very low operational costs once installed, can offer more predictable pricing due to their low and stable fuel costs, effectively zero since sunlight and wind are free. This predictability can help stabilize energy prices overall and shield consumers from the price spikes often associated with fossil fuel markets. In wholesale electricity markets, the introduction of low-cost renewable energy can drive down the price of electricity, particularly during periods of high renewable output. This phenomenon, known as the merit order effect, occurs because utilities often dispatch the cheapest available electricity generation first. Since renewables have near-zero marginal costs, they can displace more expensive and less efficient fossil fuel plants, leading to lower overall market prices. The shift towards renewables is also associated with long-term economic benefits, including job creation in the renewable energy sector. Jobs related to the design, manufacture, installation, and maintenance of renewable energy infrastructure contribute to economic growth. Furthermore, regions that invest in renewable energy can reduce their energy import costs, keeping more capital within local and national economies. Despite the positive impacts on energy prices, the integration of high levels of intermittent renewable energy sources, like solar and wind, requires investments in grid infrastructure and technology improvements to manage reliability and ensure consistent service. These costs must be carefully managed to ensure that the benefits of lower energy prices are not offset by increased infrastructure costs. Overall, the growing incorporation of renewable energy is reshaping economic landscapes by driving down energy costs, stabilizing energy markets, and fostering economic development through new job opportunities and energy independence. Subsidies and government incentives are vital tools used to promote the adoption of renewable energy technologies like wind and solar power. These financial supports aim to mitigate the high initial costs associated with clean energy projects, making them more accessible and appealing to a broader range of investors and consumers. The rationale behind such incentives is straightforward. By lowering the economic barriers, governments can accelerate the shift toward a low-carbon future, which is critical in the fight against climate change. One common form of support is tax credits and rebates, which reduce the amount of tax that individuals or businesses owe if they install renewable energy systems. These incentives directly decrease the upfront costs, making renewable energy installations more financially feasible. Similarly, feed-in tariffs offer long-term contracts to renewable energy producers, typically guaranteeing above-market rates for the energy they generate. This arrangement ensures that investors can recover their initial investment and earn a reasonable return, which encourages more people and businesses to produce renewable energy. Moreover, some governments provide grants to cover part of the costs of setting up new renewable energy technologies. These grants are particularly important for startups and research institutions that might not have sufficient capital to cover the initial expenses. Governments might also offer low-interest loans to make these projects more appealing from a financial standpoint. Another significant incentive is net metering, where energy producers can sell excess power back to the grid. This not only provides an additional revenue stream, but also maximizes the utilization of generated energy, making the investment in renewables more attractive. Renewable portfolio standards also play a strategic role by requiring a certain percentage of all energy generated to come from renewable sources. This creates a consistent demand for green energy, indirectly supporting the industry through market dynamics. However, the effectiveness of these incentives can sometimes be a double-edged sword. While they help reduce carbon footprints and foster market growth in renewable technologies, they can also create market dependencies that might inhibit innovation and cost reductions in the absence of government support. Moreover, the sustainability of these incentives can be subject to political changes and economic pressures, which may affect long-term investment decisions. Overall, while the landscape of subsidies and incentives is complex and occasionally contentious, their role in fostering the growth of renewable energy markets is undeniable. They have been crucial in helping solar and wind technologies become more competitive with traditional fossil fuels, driving significant growth in the clean energy sector. In conclusion, the total system costs of wind and solar energy, although substantial, represent a strategic investment in our sustainable future. Initial investments and installation costs are mitigated by long-term benefits such as reduced operational expenses, increased efficiency, and the positive impact on energy prices influenced by government subsidies and incentives. These renewable energy sources not only help in reducing the dependency on fossil fuels, but also promote environmental sustainability and economic stability. As the technology matures and scales up, the economic landscape of energy production is witnessing a significant shift. Wind and solar power are becoming increasingly viable, thanks to advancements in technology and strategic financial support from governments worldwide. These efforts not only make renewable energy more accessible, but also help in stabilizing energy prices while contributing to job creation in new sectors. The journey towards a fully renewable energy future is fraught with challenges, including the need for substantial upfront capital and the complexity of integrating these technologies into existing grids. However, the long-term benefits, environmental conservation, energy security, and economic resilience far outweigh the initial costs. As we continue to innovate and improve upon these technologies, and as policymakers craft more robust and supportive policies, the path to a cleaner, more sustainable energy future becomes clearer. For stakeholders at all levels, from government to consumers, the message is clear. The investment in renewable energy is not just about creating power, but securing a healthier planet for future generations.